Okay, so as you can see here, you can see the receiver, which is a OLED screen display with ESP32 on ESP-NOW, and communicate with the GPS. The GPS is sending information, and you can see the LED is flashing. That means that the data is arriving to the receiver and the sender. So the GPS is a sender, and it's also ESP32, and they are connected via peer-to-peer, or it's ESP-NOW. So what happened? You can put the GPS somewhere else, and you can receive the data at quite a distance. Okay, and it's not using Wi-Fi. It's using ESP-NOW, which is a type of service which is only excluded for ESP. It's included in ESP32 microchip. You can see now that it's got 4 satellites available, 5. It goes up to 6 and 7, 8 satellites. It picks up satellite. It's got the speed, so if you had to put it in a car, it could manage your speed. It has my latitude and longitude and where I am at the moment. Okay, so it is working perfectly. It's sending data as it should. And as you can see here, I put them on a separate battery, so they're not connected to the computer either, so that they can be independently used. Right. So in this shot, let me see again. Now it's got 3 sat, picking up 3 satellites. The speed is 1.1. Okay, I mean there's no speed, it's not moving. So yeah, that's the way it works. And one of the reasons why I put this on a ESP-NOW, because when I want to show how the GPS works, and the problem is that the LED stops flashing and stops sending data if it's not on the windowsill. But if it's on the windowsill, it's not on your desktop, then it's not easy to manage. Okay. So, but this is also good. You could connect it to via Wi-Fi and the GPS. Put it in a car as a tracker, and you can monitor it from whatever distance. Okay, you can see that the LED is still flashing, and it's picking up now 6 satellites. So the the GPS is a very small GPS. is a Neo 6M from a company called Blocks. Okay, right. Let's go through this quickly. This is the GPX coding. Okay, so we have the ESP-NOW library, and we have the tiny GPS Plus library that you have to. I'm sure you have it already, but if you don't have it, you just get them here. See this mark. All right. So I'm using on the chip the GPS RX, which is on the chip. It's pin number 4, and the TX from the GPS goes to number 4. Okay, and the RX is not connected, because remember that there is always the GPS has got RX and TX. The RX does not need it in this case, so there is no wire. That's why I put -1 here on the GPS TX, because it would have been number 5 if we need it, but we don't need it, so we're not going to plug it in, and we put it -1. Okay, so your MAC address, where you leave the 0 time here, 0 time, and you just change the FF. Okay, so when you upload the OLED, the receiver code file sketch, it will give you the MAC address on the serial monitor, and you just click here and you go and read it, and it will give you the MAC address, and then you will type each individual couple of numbers on each position here. Okay, This is where you're going to put your MAC address. Otherwise, it won't be able to send the information to the OLED screen. Alright, so this is where you get your serial monitor, you can see next to you. Alright, and that's it. There's not much else to talk about. And I will publish this, I will publish them on the GigaHut. Okay, so that's it. This is the GPS code. Now let's go and have a look at the other code. Okay, here, sorry, I've put the camera higher so you can look at, you can have a look at the both receiver and sender, how they operate. And there is a little antenna from the GPS. The GPS LED is still flashing, so it's still collecting data. And the triangulation now shows 5 satellites on the receiver, the display OLED screen, which show the data coming from the GPS. Okay. Just keep in mind that the ESP32 is not that easy to connect GPS. I struggle a bit, eventually I found it. I use pin number 4 and it's only one wire directly from TX to software change to RX. Okay. So I've tried the other ones, the 2021, but it didn't work, and actually was a problem to upload the sketch, but otherwise now it's working. Alright, so now we are on the receiver, the OLED screen. Obviously you see you still have the same library, ESP-NOW.h. Obviously you got your Adafruit 2 library for the graphic and the GFX, and to initialize your OLED screen. Okay, so this one usually you should have them on. If you don't, you go here and you download them. Okay, so that's it. This is the OLED screen. It's a receiver, and here it will parse all the information. Information will come and display on the screen. On your OLED screen, it will show your latitude, your longitude, the speed, and it will show you how many satellites it will eventually pick up. And remember that it will take a few minutes before that happens. Okay, so the key feature here, it's a real-time latitude, longitude, then the speed and the satellite count, okay, as we showed earlier on. Then we have a wireless range up to more than 100 meters. No internet or Wi-Fi required, and low latency because it's using ESP-NOW communication. Okay, and on the hardware side we have a 2 ESP32. In my case, it's a C3 node MCU boards, and then I use a Neo 6M GPS module, as I explained earlier on. And then we, the display, which is a 0.96 OLED display, I2C. It's a fully functional vehicle position display on a desk monitor. Okay. Okay, the pin connection. I've got the GPS. It's connected to the TX. From the GPS the TX goes to the GPIO4. Then on the OLED screen, it's the SDA is on GPIO7, and the SEL is on GPIO6. I think that's explained everything. Okay. Also, you've got to keep in mind that this type of GPS, which are very small model, they don't go on immediately. So before the LED start to flash, sometimes it's red and other ones is green. Before the LED start to flash, you've got to wait a few minutes. But also, I'm going to add a file, is a test file that will test the NIMEA of the data coming from the GPS before even you try to connect it all up, because you got to wait 10-20 minutes sometime and there is no data, so you don't know if it's going to work or not. So it's all wait and try and error. But the best is to test the pin first, and then depends, because you might have a different ESP32 from my one, and you're going to battle to look at the correct pin sometime. There is a light, an LED on top of most of the ESP32 that if it sometimes it flashes blue, red. So if it's blue and red, isn't that great? The connection is not going to work 100%. The best is when it's green. And do not use the RX and TX on the chip, because that is usually it has priority for the USB. So maybe what you can do, you can code on that, which usually in my case it was 20 and 21. You can code it, but then when you upload, you're going to disconnect it, and once it's uploaded, you reconnect it. Otherwise, it won't allow you to upload because it's in conflict with the USB. Okay?